Okay, welcome. This session is called Introduction to Modular Development. It's one of a number of sessions that we're doing in this room. Some of you may have been at the earlier session today on Prepare for JDK 9. That was not dealing with the module system, but it was dealing with some of the implications of the module system. In this session, we're going to introduce the module, introduce some of the concepts. Alex Buckley and I are going to do an advanced session later on after lunch, which directly follows this one. And then later on today at 5:30, and Alex Buckley is going to do an under the hood for the very, very advanced session. These first three are going to be repeated as well. So if you missed the first one, you can catch up on it later on in the week. We then have a hack session in this room tomorrow morning. Just doing some hands-on and take questions for people who actually want to try it out. So this session, as I say, is an introduction session. It's a very, very gentle introduction to modules. Oh, and my name is Alan Bateman. I work on the JDK in Oracle. We've been working on the JDK forever. For the last few years, been mostly focusing on the module system and the modularization of the JDK. So first slide is, what is a module? Now, for this session, we're going to be using pretty dumb module names. In the advanced session this afternoon, we will have more sensible and more real module names. So just bear with me for the first half of this session where we use these dumb module names. So I want to start at the beginning on what is a module. And what is a module? Well, it's basically a self-describing collection of code and data. The important thing from this slide is to know that it has a name. And if you saw Mark's keynote, you would have picked up on this as well. In this example, our module is called CON5118, not very imaginative. What's in our module? Well, it's a collection of packages. All the code in the module is organized by packages. In this module, I'm just showing the names of 4 types. They're in 2 different packages. CON5118 alpha, and then there's an alpha and an alpha factory type in there, and then there's a CON5118 beta package with a couple of types in that as well. Some modules will have native code, some modules will have additional resources, configuration files. I'm not going to deal with any of that in the introduction session. We're just going to talk about modules that have code in this session. The module's description is expressed in a source file called modulinfo.java. So in this module system, there is a file called modulinfo.java that is in your source tree and positioned by convention at the top level directory of the source tree. So I had 4 types in my module in the first slide. This is how they might look in my source tree. So there's a .java file that corresponds to each one of those types. The modulinfo.java is at the top. What is in that modulinfo.java? There's the module and the module name, and I haven't said anything about what's in the module yet, so I've just put curlies and we'll expand on that as we go through the slides. So the syntax is module name, open curly brackets, and then we'll have something that will describe the module. So the way I'm going to introduce these modules is I'm going to start by talking about dependencies, and we'll move in a moment to talk about, in a few minutes, to talk about encapsulation. So in this module info, there's typically one or more requires clauses that indicates what other modules that you depend on. This is very, very simple. In this example, we've got CON5118. We just think of it as a library, and it has a dependency on another library, CON5118. So we have 2 modules now in our slides so far. If we had multiple requires, then they would be listed down there, and we'll introduce a few more modules in a minute that will have more dependencies. Now I'm going to introduce a 3rd module. So we've had CON5118, which is our library, depends on CON5118, another library. Now I'm going to introduce yet another module, CON51app. This has a dependency on 2 modules, CON51 and Java SQL. What is this Java SQL? For now, just think about it as the module in the Java platform that has the JDBC API. It's the one for accessing databases. In our module info for this module, I've got 2 requires in there, because that corresponds to this little part of the module graph that we're seeing on the slide. Now let's expand this a little bit, and I've introduced a module right down at the bottom in this little module graph called Java.base. Java.base is where the core of the platform is. This is where you find Java-lang object. Every module depends on Java.base, whether you like it or not, because every module eventually, if it has code, of course, will somehow extend Java-lang object. So these dotted lines here are just to point out that there is always a dependency on Java.base. In this, I've built up my module graph a little bit here, or my dependency graph, by including the 3 modules that we've introduced in the slide so far. I'm now going to expand this a little bit further and look at the Java SQL module. So the Java SQL module, this might seem strange, but it has a dependency on the Java XML module and the Java logging module. We'll see a little bit about the Java logging module in a few minutes. Why does the SQL module have a dependency on the XML module? That is because there are types in the JDBC API that are XML types. So there is actually an XML SQL type in the JDBC API. So that is why that dependency is there. All of these modules, they of course depend on Java-base, because as I said, every module depends on Java-base. So this is our module graph. Now I'm taking a little subset of that module graph. I've just taken just one little part of it that was in the right, and if I go back, over on the right here, confu bar to SQL to logging. I'm just going to look at those 3 modules. And I want to start looking at what code might be in those modules. And we'll just look at those a bit more closely. Okay, so let's look at the Java SQL module for starters. So our Java SQL module has a class in there called driver. I guess most people actually know there's a Java SQL driver. That's one of the most commonly used classes in the JDBC API. It has a public method in there that returns a logger. Okay, so the logger is in this other module down at the bottom. It's in the package Java Util logging. I've now got code in my application module that is invoking that method. So it has a reference to a Java SQL driver and is invoking that method. So let me see how this works. So we're calling the getParentLogger, and then I'm going to invoke the log method on the logger that the driver is giving me. Okay, so how do I relate to this in my little dependency graph here? Well, I can't see how that's going to work, because I don't have a dependency in my confu app module on the logging module. Maybe I'm forced to introduce that dependency. Do I have to do this? That would be very inconvenient for me, because it means that I now need to know the transitive dependencies of any of my modules that I depend on, and if they've got APIs that are exposing other types in other modules, then I've got to know about those. That's not very intuitive and is a little bit error prone, particularly if they'll change over time. So in this module system, there is this notion of implied readability. So if a module depends on another module, it's said to read that module. In this example, what we do is we have a module confu app that depends on or reads Java SQL. Java SQL reads logging. And the way for the SQL module to be a good citizen and let the consumers of its module know that it's returning types in some other, or it's got method signatures that are in some other module, is it declares that dependency in a special way with called requires public. And what this does for the module system is it means that the application module here, confu app, will read the Java logging module. This is something called implied readability. So the confu app reads the SQL module because I require it, and it also now will read the Java logging module because the Sql module has essentially re-exported that. So now what we will do is we will add these implied readability edges to our module graph and see where we get to. So the new edges that are added to that graph, so I went from a dependency graph, now I've got my complete readability graph. These new edges that I've added based on this new concept of implied readability are these yellow edges or orange edges in this graph. So there's one additional one that I haven't shown, and that is the Confu app to Java XML. This is also because of implied readability, because as I said a few minutes ago, the Java SQL module has some types in there in its API that are XML types. Okay, so that's how we went from dependencies to readability graph. I now want to actually look at another concept in the module system, which is encapsulation. So in our module info to date, we've just been requiring other modules. This next keyword that I want to talk about is the exports. If I am a library developer, I can essentially partition my module into two. The API packages that I want people to be able to use because they are part of the API that I export. And then I've got my internal types that are in packages that I don't want anybody to use. So in this diagram here, I've taken the Confu bar module. I've divided it into two. I've got my Confu bar alpha and beta packages. That is the API that my library exports. They're over on the left. My internal packages, even though it contains public types, I don't want anyone using them. These are only internal to my module. These are not exported. So in the module declaration, the way this is done is exports, the name of the package that I want to export. So in this module declaration, there are two packages exported. There are some internal packages that are not exported. I'm now going to bring the two concepts that we've talked about together to talk a little bit about accessibility. So we've got our application module and we have our library module. Our application module is Confu app. Our library is Confu bar. Our Confu app module reads because it requires the Confu bar module. And what this means is that it can access the public types in the exported packages of Confu bar. It cannot access anything that is in the non-exported packages. So this big red X on the right here is, these are my internal packages. Even though this module, Confu app, reads my module, it cannot access any of the types in that module, even if they're public. And just to enforce that is, let us suppose that read edge is removed. Confu app does not read Confu bar. That means that no types within that module are accessible. If I go back and reintroduce the read edge, they're accessible again. So the important things to understand about accessible is a type is accessible if it's in a module that you read and it's also a public type in an exported package. You have to have both together in order for a type to be accessible. The main thing to take away from this is the notion of public changes with the module system. Alex has, for the Under the Hood presentation for later on this afternoon, will go into a lot of detail to explain essentially the different types of public. But this is a huge, big change to the platform because there is code out there that will assume that if a type is public, it must be accessible. The module system changes that. So that's the one thing to take away from this part of the presentation around the concepts. Now I want to switch gears a little bit and just talk a little bit about moving on from concepts, showing you some of the command lines as to how you compile modules. I want to talk about running modules. And I also want to come back to the Java SQL module and the Java logging module that we had there to explain what they are, because they are platform modules. Anyone that has come to Java 1 over the last couple of years will have seen spaghetti diagrams. This is a cleaned up version of our module graph. where we have, over time, cleaned up the JDK so that we can have both standard and JDK modules. This is a nice, this may look complicated, but it is significantly cleaner from where we were a couple of years ago. There's no cycles in this graph. There's clean dependencies. We can build, and the JDK, a module at a time. It's taken us a long time to get there, but this is what we have at the moment in JDK9 and in the Jigsaw builds. For those that have tried the Jigsaw builds, you will actually be able to run the listmods command and see the complete list of modules that are in the JDK. The modules that start with java.something are standard modules. They're Java SE. In the examples that we've had to date, I've talked about Java base. We'll probably see that in that list. It's third or fourth one down, or third one down there on the list. If you search, you'll be able to find the Java SQL, the Java XML, the Java logging modules. We've been able to divide the JDK and the standard APIs into these set of modules. There are also modules that are named JDK.something in this list here. These are JDK-specific APIs. They're not Java SE standard APIs. Some of these modules are tools. Some of these modules are service providers. They don't export any API. Some of these modules export JDK-specific APIs. In the presentation this morning where we talked about internal APIs, I introduced the idea about java.star being standard and then sun.star being internal. There's in the middle, there's a bunch of APIs that are com, sun, something, and there's endless confusion as to whether they're supported APIs or not. The module system fixes all of that by having it clear that only the supported APIs will be exported by these modules. So if you try out the Jigsaw builds, you'll be able to see the full list of modules. So I want to move on now and just show some of the command lines we'll first start compiling some modules and then we'll start running and see how it comes together. Okay, back to the example that we had in one of the first slides. I'm going to compile here one of the leaf modules, which was the com.sun.baz module. This is the javac command to compile this. Javac takes my Java source, compiles it, and outputs a corresponding tree of .class files. And this is exactly what happens when you're compiling a module. The module info.java gets compiled to a module info.class in the build, output, whatever directory you want to call it. In this javac command, the -d here, if you're familiar with the javac command line, then that's what the output directory is. And by convention, we're using the module name as the directory for both the source and the output/destination directory. So this is one javac command to compile one module. Before I move on and explain some other javac commands, I need to introduce something called a module path. This is the module equivalent of a class path, if you like. There's in the module system and in the Jigsaw builds, there is a new command line option called module path. There's a shortened form version of it, MP. So we've got class path with a CP. The value of the module path is essentially a sequence of directories where to find modules. When I want to compile a module or I want to run a module, and where does com.foo bar? And I have to go and I will be able to search through the module path to find it. Later on in the presentation, I'll talk about packaging and some other details, but just assume it's a sequential search through first directory. Does that module exist? No, it doesn't. Second directory, does it exist? No, it doesn't. Third directory, it exists. That is where the module will be found. So it's a familiar concept of how do you find modules for those that are familiar with the class path. There's a number of significant differences between this and the class path in that you cannot have multiple modules of the same name in the same directory. So if I put two versions of some module in dir1, module system said, no, can't do that, can't figure out which one you want. So it avoids those kind of errors. So now that we know what a module path is, we will introduce it into the javac command that we had, and we will compile one of the other modules. So remember in our little module graph that we had confu bar depends on confu baz. How am I going to compile confu bar? Because it has a dependency on this other library, confu baz. So the way this works is I'm going to exactly the same javac command, but I give it the module path so that it can look in that module path to find the modules that I depend on. And exactly the same as the previous example, we go from .java to .class. Same convention as previous is the directory names on both the source and the output is the module name. Now I'm going to move on. I've got my modules compiled. Let me see how I'm going to run them. Okay, here we have a new command line option, -m, to give it the main module or initial module. This looks a little bit complicated. We'll simplify this as we go through some of the other slides. For now, just bear with me. Javac has a module path option. Java Launcher has a module path option. The main application module is confu app. The main class in that module is confu app main. -m, I want to run this module, and this is the entry point or the main class in that module. And that's what this syntax module / main class is. As I said, we'll make this simpler in a few minutes. I want to show what happens now when we run this. My initial module or my main module is confu app. It has a dependency on confu bar, on Java SQL, and of course Java base, because everything depends on Java base. So what happens is it locates module confu app. It looks at its module descriptor, figures out what it depends on. Then it has to compute the transitive closure to get the full set of modules that are in this module graph. So it's essentially generating this module graph when I run the java-m. So I go from here to here, and this is my module graph again that we had earlier on in the presentation. This is all computed at startup when I run the main application. So the important things from that is because it's located all of the dependencies, transitive dependencies, we know that there's nothing missing. When we go to the advanced talk or we go to do under hood, we can actually prove a whole bunch of other correctness issues around this module graph. I'm not going to get into it in this presentation. But we can ensure that we're actually starting up with what we call a reliable configuration. If you're interested to see what really happens at startup and see more of the detail, there's a diagnostic option. So if we're playing around with the jigsaw builds at the hack session tomorrow morning, this might be one of the things we might actually try, is run it with this xdiag resolver option, which is essentially a diagnostic option to get it to do print out some traces during startup, so you can actually see where it locates the modules and what depends on what, and you see a whole bunch of other details. The output that you see from that tracing option is essentially how it's actually building up this little graph that we had on the previous slide. Okay, everything that we've done so far has been very basic command line, compile, got my output directory, everything is exploded on the file system. I want to spend a few minutes just talking about packaging my modules, because packaging is important because I don't want to be shipping down a big tree of class files around the place. Okay, jar files. We're all familiar with jar files, I hope. We can package up a module as a jar file. We call it a modular jar. A modular jar is just like a regular library, except it has a moduleinfo.class in there. That is the compiled form of the moduleinfo.java. I've got a command here. This is an updated version of the jar tool. So the jar tool has been upgraded very significantly in the Jigsaw builds to support a whole bunch of new options related to modular jars. So I'm creating my jar file with this command. So there's a -- create, which you may be familiar with jar C. This is exactly the same thing. Give it the name of the archive. In this case, I'm going to package up the application module into app.jar. I'm going to use this option to indicate what the main class is. So as part of packaging, I can add other information and other metadata to the module. And one of the things I can add to the module when I package it up is indicate what its entry point is. So in this example, the entry point is confu app main. So I'm going to indicate that when I'm creating the jar file, and then I package it up, and I've now got a modular jar. Let's look at a modular jar. So there is a print module descriptor, or the shortened version of that is -p, where I can look at the jar file and I can understand what its dependencies are. I can understand what it exports. Because for this example, I've packaged up the main application. It doesn't actually export anything. It's the libraries that it depends on export some API packages. But for a main application, I can see what its main class. And there's other things in a more advanced example we might see being printed out from this. So this is really useful because if I've got a jar file that's packaged as a module, I can see exactly what it depends, exactly what API that it provides. Now we will go back to our Java-M and see how this looks. Our command line has now shortened. A few minutes ago, we had to go and we had to specify to the Java launcher what the initial module is, what the main class is. Because the initial module knows what its main class is, I don't need to specify that. So this gives me a shortened command line, which is nice. So with our modular jars have another wonderful property in that it gives us a story for how you can have a library that works in 8, that works on the class path with 8, but works as a module in 9. That is an important thing to understand about a modular jar file. The module info, remember it's module -info, isn't a valid Java identifier. It's not going to be recognized as a class file by older versions of the platform. It'll be just ignored. So what this means is that I can exploit that to be able to have a library that works in 8 and 9. It can either work on the class path or it can work on the module path. So this is all part of the migration story. And we'll be talking a lot more about migration in the advanced talk later on. So I'm going to come back to one of my libraries, which is the Baz library. It's packaged as a modular jar, but I'm going to use it on the class path, and it just works. Now, there's an assumption here that I've compiled that library source target 8. I haven't, or -release 8 if you're using the newer version of Java C. Of course, if I compile it for 9 and I put it on the class path of a JDK8 installation, then it's going to complain that the class file version, or it will eventually complain the class file version has been revved and it doesn't recognize it. But assuming I've compiled it for 8, then I can use it as a regular jar file on the class path. Now I'm going to take that same jar file and I'm going to put it on the module path in 9. So all of my libraries now are on the module path in this example. So my Baz is being loaded as a library here, as is the main application and the other libraries. One other thing we can do, and this requires a little bit of a deep breath, but we can actually mix the class path and the module path. And this is also important for migration, because over time you would like to see that the common libraries will get migrated to modules, but the rest of the system hasn't been migrated to modules. So I can continue to have the rest of the system on the class path as before, but anything that has been migrated to modules, I can have that on the module path. Now, this requires a little bit of thought because I'm not giving it an initial module. Remember when in the previous slides where I showed the module graph and what happens at startup? There isn't an initial module to think about here. There could be 1,000 libraries, modular jars sitting in that mlib directory. How do I know which ones that I'm supposed to load? And this is the reason this example has an add mods option. I need to tell it that I want to make use of this module CON5118. There's nothing in my code on the class path that tells me what my dependencies are. Therefore, I'm mixing the class path and the module world, so the -add mods is telling me what these modules that need to be resolved. And CON5118, if it's got all these other dependencies, they will get resolved then as part of this initial startup process that I talked about. Okay, so that is a little bit of introduction to some of the possible migrations. I next want to spend a little bit of time just talking about linking. So for those that were here at the Prepare for JDK 9 talk this morning, I talked a bit about JEP 220 and the modular runtime image. I mentioned a teaser in that the possibility that we could actually take an application, a bunch of libraries, and create a custom runtime image that contains only the parts of the JDK that application needs. And I can do that through this process of linking. The linking and a linker is something that has never really existed in the Java ecosystem. We've always had compile to classes and we run. There may be some packaging in there, of course. There has never been a link step in there. What the module system it brings along is an optional link step where we can actually link a bunch of modules together and the current linker will, in the current builds, will generate a custom runtime image with just the modules and their transitive dependencies that you need. So, I didn't move on and just show what it actually looks like. So, I have more slides on this in the previous talk, but essentially just think about it as I've got a set of modules, the transitive dependencies. I'm going to produce a modular runtime image. Modular runtime image, think of it as like a JRE, but it's a modular JRE. It has a bin directory for launchers. It has a conf directory for user editable configuration. Ignore everything else in it because it's implementation specific. This is the way the JDK 9 builds are actually been shipping for the last almost a year now. We've moved to this modular runtime image, got rid of the rt.jar, tools.jar. Everything is in a much more efficient representation in the runtime image. And this is the modular image. And the modular image is not limited to the JRE or JDK. It can be any set of modules. Okay, I hope this is readable at the back. This is a JLink command to create a runtime image that has one and only one module, Java.base. Java.base is the core of the system. It does not depend on any other modules. What I'm doing here is I'm running the JLink command. That's the JLink is the linker. It has an option to give it the module path. What's that for? It's to where to find the modules. There's an add mods, just like Java add mods, which is what modules to add to this when we're creating this image. And I'm giving it an output directory as to where to create the image. This is the most basic JLink command that we have, and will create a runtime image. And when I run the Java list mods, you might remember in one of the early slides, I did a Java list mods on the full JDK, and I had a screen full of java.star and jdk.star modules. This one runtime image that I have here contains only one module. In an embedded system, this might give me a runtime image that's only 10 or 12 megabytes, and that's really nice. Now let's move on for our JLink command, and I'm going to create a runtime image with my confu app module. Now my confu app module, remember our little module graph, it depends on confu bar, which depends on confu baz, and depends on Java SQL and XML and logging. We will create a runtime image with that this module. All of its transitive dependencies will be linked in, and we get a small runtime image that only has 8 modules in it. That's really, really nice. So what we see from this is that I have created a runtime image that has Java modules, standard modules, and also some of my own libraries, and also my own application, and they have been linked in together. Okay, I've run ahead of myself, and this is where I've ended up on the. We have more slides in here on testing that we thought were a little bit too advanced, so we moved them to. We talk about them maybe at the hack session tomorrow. But the main thing to take from this session, I realize it was shorter than you might have expected, is just really wanted to introduce you to some of the basic concepts. So we've talked about modules. A module is a name. It declares its dependencies. It declares its exports, and also introduce you to some of the basic commands that we have with Javac and Java, and the fact that they're being modified to support support modules. So we're back in here again at 2:30. Alex Buckley and myself are doing the advanced session. This one is primarily focused on migration. We'll get into a lot more detail on how to move libraries to modules. Alex is back here then again at 5:30, again this room, to do an under the hood, which is a more advanced session. And then we're back in here tomorrow morning for some hands-on, for those people who actually want to try out Jigsaw. We'll take questions. More information. So 2 links. Project Jigsaw page in OpenJDK has a link to all of the JEPs and all of the other material and documents that we have. There's the mailing list, Jigsaw dev list. There's also a link there to the early access bills. You can just Google for them if you can't read it from the back. And that is early access bills. So that's it. So Mark, do you want to come up so Mark Reinhold was supposed to be talking today as well, so he's going to come up and help answer questions if there's questions. Okay, there's no microphone, so what we did in the earlier session is either repeated or come up and read into the microphone or shout into the microphone.
I was going to ask, is the public not accessible thing at only the runtime or also on the compile time?
Okay, so the question is if something is not accessible, is it both non-accessible at runtime or also at compile time? The answer is both, yes. I should have made that clear during the talk, yes. So you will actually get a compilation failure if you actually you've got some reference to some type that's in a non-exported packages, your code won't compile. So and then if you do compile it through some ways, then it'll fail at runtime.
And that comes into effect only when you create the module class, right? So until you create the module class, public still gets compiled.
Okay, I didn't quite catch. Did you say clear?
You have to create the module class, which actually defines the imports and exports.
Yes.
Until you create that, it's still accessible, right?
Yeah, if it's exported and it's public and you have a dependency on that module, then your code will compile and run.
Okay.
So there is no more runtime.
Speak into the mic, please. We're on a video stream.
Okay.
So there is no more runtime and compile time dependencies. Everything is both.
That is okay. So for the recording is the question again was whether these module boundaries apply to both compile time and runtime, and the answer is yes.
Okay. And does this make OSGI like redundant maybe, or I mean this seems very similar to OSGI concepts where you export and import the packages.
Could we get the podium mic? Thanks.
Thank you. There are some similarities, but this is quite a different module system than OSGI. OSGI does a whole bunch of other stuff that maybe you need, but often you don't. And OSGI doesn't do some of the things that we need for modularizing the platform itself. So that's why it's different.
Thank you.
So is there any solution for optional dependencies?
Yes, the solution for optional dependencies is services. Yeah, in earlier prototypes of Jigsaw, there was a notion of optional dependencies, but we found out that working out the semantics of them got really, really hard. And I think Alex ultimately convinced us that this was just a bad idea. And at least our experience in the JDK and some other code bases we've looked at is when something's optional, it's often very straightforward to refactor it as a service. And in fact, modules, things we haven't shown today are, modules can also declare that they provide services, that they require services, and that's all hooked up with the existing service loader API. So if you need some optionality like that, services are generally the way to go.
Hi, two small questions about JLink. First, it creates a build that is specific to the platform in which you ran JLink.
Yes.
If you run it on Linux, you'll get a Linux build.
Yep.
No option to, if you run it on Linux, auto-generate a Mac build or something like
Oh, okay. So there is you can build it for other target platforms. The most obvious is when you're doing cross compilation to Linux ARM or something like that. You're not going to run the tool on the embedded system. You'll run it on some host system. So
Okay.
yes.
And is there a way to, for instance, in JLink itself, specify the main class to run? So that you don't have to run that specific Java binary and then specify the main class. Basically solve the problem of
Right.
self-executing Java.
Right. So in the current version, does actually generate a very basic launcher. That is the name of the application. There's more work that'll be needed, I think, to make this a bit more smarter and integrate properly with the native toolchain. But it does actually generate a wrapper at the moment around Java for the application. Anything that has a main class.
JLink is the foundation for other tools as well. For example, the Java packager that was originally started out as the Java FX packager is being enhanced they're rebasing that on top of JLink. So some of the additional stuff that you need to do in order to build a shippable Mac app that you can put in the Mac App Store will be done by Java Packager. It'll use JLink to get most of what it needs and then do the additional, really Mac OS specific stuff for that.
So there will be a JEP on JLink soon. It's in the Jigsaw builds, but there isn't a big detailed JEP. That we'll have to add that soon. So that'll detail all of its capabilities and options.
Thank you.
Will you be able to version modules? Or?
So versioning is a fun story and a common topic. Do you want to answer this? Get Alex to answer.
I have a very simple attitude to versions. If I see them coming down the street, I go to the other side of the street.
Yeah. So in the proposal, the initial view we've taken on versions, and this is after again experience with prototypes where we had very deep support for versions, is versions are, from the perspective of a module system embedded in the VM and the language, versions are almost extracurricular, right? They're useful information. We have a way to embed a version string in a module when you package it. We have a way to query it. You can get the version string out. You can compare them just so there's at least one way to order them and compare them. But the view we've taken, at least for now, is that versioning is this fantastically hard problem that other tools like Maven and Ivy and Gradle have solved, maybe not great, but well enough. And we don't see a need to replicate that kind of solution or try to do an even more perfect solution involving a SAT solver or something really high tech inside both the compiler and the VM. That seems like massive overkill. So the general model here is, we're not trying to go out and replace the existing ecosystem tool chains. We're not trying to replace Maven or Ivy or Gradle. We're trying to provide a foundation upon which they can build. So it will still be up to your build tool to help you select versions, deal with version conflicts, and so on and so forth, and make sure you get all the right modular jars on your module path. Once they're there, then the module system at both compile time and runtime will do the right thing. It'll be able to report version strings as documentation and in exception messages and so forth. But it will not try to do something clever when it comes up to a conflict. It'll just say, oh, no, you have a conflict. Go fix your POM or whatever you need to fix to make it work right. Now, is this the absolutely correct view? maybe not. But when we realized that this was a potential way to simplify what we're doing, we found it incredibly attractive.
Hi. I'm a performance engineer, so my perspective is warped. At any time at the Java...
Worse than that, you're a GC engineer.
At the Java C level or the JLink level, can you do cross-module optimizations, like inlining or constant propagation or anything fun like that?
Absolutely.
Yes.
That is one of the longer-term plans for JLink is one of the really attractive things is the ability to do whole program analysis. You've got all the modules, both modules from the JDK, from your application, from libraries you got from Maven Central, whatever. JLink can look at them all at once. In fact, JLink already has a basic plugin architecture. So you can plug in things that will do filtering, like throwing out debug symbols or doing some basic optimizations. So that's part of the long term.
Follow-on question is, do you allow dynamic class loading, and does it ever invalidate any of those optimizations? If somebody cons together a class path to something that wasn't in the modules, does it just throw an error, or?
Oh no, the class path is still fully supported. If you have an application that spins up custom class loaders, URL class loaders, something else, that'll still work. The class path is still there. If you come to the next session, you will learn, or is it the next session or under the hood?
It's
The next
for
one. Sorry. Is it advanced or under the hood? That's right. In Under the Hood, Alex will explain how we deal with the class path. So the class path is treated actually as a very special, an instance of a very special kind of module. It's an unnamed module, kind of like the unnamed package.
But what if that invalidates some of those optimizations you did in JLink?
Oh, it won't invalidate them because we will be able to detect for conflicts.
Hi. Your example was good, but it was only particular to one module. What about third-party systems? We use a lot of third-party libraries, right? They may not have migrated to module or something.
Come to the advanced session.
right. We deal exactly with this discussion in the advanced talk at 2:30.
Yeah, we've thought about this a lot. We have a
2:30 here in this room. Oh, sorry for the recording. Maybe it wasn't picked up. The question was, what about all these third-party libraries? How can you make those modules?
And the short answer is, in many cases, you don't have to right away.
So how does the module system change JNI bootstrapping?
How does the module system change JNI bootstrapping?
Okay, so
Does it?
Startup is very different, but if you're using, if you mean JNI bootstrapping, I presume you mean the JNI invocation API.
Yes.
It works exactly the same as before. Okay. And if you've got your own native launcher, then it can pass in these options to specify module path, and it just works.
How do the new visibility rules interact with introspection?
There are no new visibility rules.
Well, okay.
Visibility.
Yes,
Come to Under the Hood.
right.
Question. Suppose I want to have access to a class in a package that is not exported from the module. Is there anything I can do to override this restriction?
Is there anything you can do to override the restriction when a package is not exported? Yes, you can use a command line flag to break encapsulation.
Yes, we used this, by the way, in the Prepare for JDK 9 talk this morning. So you might get the recording of that or get the repeat later in the week.
So if like A requires B and B requires C, so then when you define A, do you have to say A needs C, or it can be like a lookup by B?
It'll be looked up. That's all. Transitive closure for the win.
Yes.
Thank you.
Out of curiosity, how does the public non-accessible classes work for Javadoc? Is that still going to be made
Sorry.
for generating Javadoc? Is that going to be described the same way as any?
So we are upgrading Javadoc so that it understands what modules are and displays modules along with packages and classes and everything else. And if a class is in a package that's not exported, then by default Javadoc will not generate any documentation for it.
Okay, I think I'm kind of glad I finished early because
One more taker?
later. Okay, I think we're done. Thank you.
All right.